let's talk briefly about the properties of numbers. And knowing the properties helps you with mental math, or to be able to do math in your head. First of all, we have the commutative property, and it means that changing the order that you work the problem does not change the sum or the product. Keeping in mind that sum has to do with addition, product with multiplication. In other words, if you were to add 5 plus 4, you get 9. And even if you flip-flop or you put the other direction, 4 plus 5 still equals 9. That means addition is commutative. Likewise, multiplication is commutative. 6 times 3 equals 18, and reverse that, 3 times 6 equals 18 as well. Continuing on with the commutative property, I want to repeat, addition, 7 plus 11 is going to give you the same value as 11 plus 7. In multiplication, 4 times 5 is going to give you the same product as 5 times 4. Now, subtraction does not work that way. Subtraction and division, neither of these are commutative, because 10 minus 6 and 6 minus 10 are not the same thing. Same as 12 divided by 2 and 2 divided by 12, not the same thing. So a helpful hint for you to use with the word commutative. Think of a commute, and when a person commutes, they're going back and forth between two places. For instance, Stillwater is just about one of my most favorite places on the planet. And so if I lived in Oklahoma City and worked in Stillwater, then my commute would take me from Oklahoma City to Stillwater in the mornings, and from Stillwater back to Oklahoma City in the afternoons. So keep in mind, subtraction and division are not commutative. Commutative works for only addition and multiplication, and it's like flip-flopping numbers or values, and it gives you the same product or sum. Then we have what's called the associative property. The associative property is changing the grouping of add-ins or factors, does not change the sum or product. Again, so this time we're changing the grouping of either add-ins, which is addition, or factors, which is multiplication, and it doesn't change the sum or product either. Let's look at addition. I can add 9 plus 5 first, I get 14, and then I can add 4 to that, that gives me 18. Or I can add 5 plus 4 first, and that's 9, and add 9 plus 9 and get 18. So the grouping of addition does not matter. In multiplication, same thing. I could do 2 times 3 first and get 6, and then 6 times 4 is 24. Or I could do 3 times 4 first, which is 12, and 2 times 12 is also 24. So a helpful hint to remember the associative property is who you associate with, who you hang out in a group with. Sometimes your parents may say, I don't really know if I want you to associate with them because maybe they're not a good influence on you. And so associating is a grouping in one way or another. And when you associate or group in addition and in multiplication, it doesn't change the value of your answer. Next we have the identity property. And this is true for both addition and multiplication again. And so the identity property of addition is when you take the sum of 0 and any number, you get that number. In other words, whatever number you add 0 to, it keeps its identity. So that's called the identity property of addition. 0 plus 9 is 9. There's an identity property for multiplication, but this time it's the product of 1 and any number is that number. In other words, what can I multiply a number by to keep that number? Well, 1. 4 times 1 equals 4. So a helpful hint on this one is that numbers keep their identity. Sometimes you may talk about, I don't know, years from now, hopefully, if you start dating, and someone might say to you, you know, I just don't know if I really like you with that person, because it just doesn't seem like you're yourself around them. And so I want you to find someone that they won't take away your identity, but they'll make you better. So again, staying who you are. In order for 9 to stay who it is, when we add, we have to add 0 to it. So that's called the identity property of addition. In order for multiplication, for a number to stay who it is, when we multiply, we have to multiply it by 1. That's why it's called the identity property of multiplication. Now, this is a little fun fact, a little aside for a moment. Just so you know, most people don't believe this, but addition is binary, which means that you can only calculate 2 numbers at a time. When I tell people this, they don't believe me, because they look at numbers like this and they say, I can add those all at once. I don't have to add those 2 at a time. And so that's my challenge to you. Try to add those just 2 at a time. Let me give you an example. When I add this column here, am I not adding 2 plus 4 first? In my head even, I might say 2 plus 4 is 6. And then I say 6 plus 9 is 15. That means it's binary. I'm only doing 2 numbers at a time, adding them together. And then I might say 3 plus 2 is 5, plus 1 more is 6, so I'm really doing 5 plus 1. And then 6 plus 1 more is 7. So addition is a binary operation. As a matter of fact, so is subtraction, multiplication, and division. They're all binary. You can only do 2 at once. And that helps for when we get to problems like this. How can the properties help you? Well, they can help you add things in your head or multiply things in your head. They can also help you work out problems by organizing numbers and putting them, kind of compatible numbers together. For instance, I could add 56 and 7 first and then add 13 to that. But really, for me, it's easier for me to add 7 and 13 together because I know that that equals 20. And 20 plus 56 is 76. And so I was able to do some more of that math mentally or in my head. Same thing with this. By the way, that's just called the associative property. We regrouped, but we kept things in the same order. Here we have 4 times 8 times 25, and I've rewritten it as 4 times 25 times 8. That's commutative. I've flip-flopped some of the numbers. It doesn't change the value because these are both multiplication symbols. And then I can group things that are compatible together. I know that 4 times 25 is 100, and 100 times 8 is 800. And so some of that I did in my head. So I used both the commutative property here and the associative property here to solve this problem and to do a lot of it in my head. That is how these different properties, the commutative, the associative, and the identity property, can help you both with mental math and when you have problems that are lengthy and you have to work them out.